Good morning, everyone. Today, I'm going to start the Unit 4, that is classification. In this unit, we are going to discuss what is classification and what problems comes under classification, how probability-based classification we are going to do, logistic regression, and important metrics of this classification, that is confusion matrix, and a little bit introduction to this gradient descent. So, coming to this, what is classification? So what is classification in machine learning? How we are going to define and how we are going to overcome the classification problems. So what is classification in machine learning? Classification is a process of categorizing a given set of data into classes. So here, just see this. From unit 1, we are discussing about the problem of email spam filter. We have two types of mails, that is one is spam and one is non-spam. So this is the given set of data. We are going to categorize these mails into two types, spam and non-spam. So this is what the process of classification. And it can be performed on both structured or unstructured data. And the process starts with predicting the class of given data points. And the classes are often referred to as the target, or we can also call label or categories. So what we have divided these two, we call it as target variables, or we can also say it as labels, are two different categories. So this is what the classification in machine learning. So nothing but a process of categorizing a given set of data into different classes. And there are some terminologies related to this classification. So to perform this classification, very first thing we require is a classifier, and that we are going to give it to a model. This classification model first extracts the features, and after extracting the features, once we classify, that classification may be into a binary classification or multi-class classification or multi-label classification. The further coming slides, I'll explain what do you mean by this binary, multi-class and multi-label classification. And along with that, first we have to initialize the classifier, and then we have to train the model, and then we are going to predict the results, and then we are going to evaluate the model. So these are the terminologies related to this classification. Types of learners in classification. There are two types of learners in classification. One is lazy learners and one is eager learners. So lazy learners, what they do is simply to store the training data and wait until a testing data appears. Coming to the eager learners, they construct a classification model based on the given training data before getting data for predictions. And before predictions only, we are going to construct a model for the training data. That is what these two types of learners are there in classification, lazy learners and the eager learners. So what are classification problems? What problems comes under classification? So classification problems are the problems in which an object is to be classified in one of the n classes. One of the n classes based on the similarity index of its features that of each class. So what do you mean by this similarity index? That means by what do you mean by these classes? Classes is nothing but a collection of similar objects. Then how we are going to say that the objects are said to be similar? Just on the basis of matching features. And what are those features? It varies from one thing to other thing. So we can say these features are like color, shape, or size, etc. And these classes are identified on the basis of their unique labels. Machine learning classification problems are those which require the given data set to be classified in two or more categories. We'll be having a data set. And what is this machine learning classification problems are? Nothing but the data set should be classified into two or more categories. Suppose we have a heart disease data set. Then we have to, machine learning model has to classify that whether a particular person is having heart disease or not. Yes or no. And another example, you want to buy something from online portal. You will think you should buy now or we should wait for a couple of months to get the maximum discount. That also comes under classification problem. And suppose you are buying a car and where you have available options and which one is the best with your given budget. This is also one of the classification problem. And different types of classification problems. This is very, very important. There are three, not three exactly. We have four types of classification problems. One is binary, multi-class, multi-label, and imbalance classification. So let us discuss one by one in detail. So what comes under binary classification? What is this binary classification? Classifies the data into two classes such as yes or no. If a particular problem has only one of the two solutions, that is yes or no, good or bad, high or low, a particular person suffers from a disease or not, these are all comes under this binary classification. And below I'll show you some pictures where we represent these lines separating two different classes. And depending upon the type of problem, maybe you have a linear data or non-linear data, whatever it may be, we are going to separate the classes, but with be of different nature. So this you can see. This you can say it is a linear data where we have a straight line divided into two different categories. This we can't say linear data. Why? Because it is something different and this is not also a linear data. And how we are going to separate this non-linear data? So just we are going to use the scatter plots for classification problem. So in case of any classification problem, the simplest way to find out whether the data is linear or not is to draw a two-dimensional scatter plot. This is the scatter plot representing different classes. Here the pictures represents this is linear and this is non-linear. Okay. And we can use scatter plots to visualize them. So as it is a straight line, linear boundary, we can say that it is linear. Okay, this is not non-linear because the two classes, no linear decision boundary. If you draw this one, see one of this other same category is coming into different class. So we can't say that it is a linearly separable. Then second one is multi-class classification. It is nothing but the task of classifying elements into different classes. It does not restrict to only two classes. It may be more than two. So examples of such things are classification of news in different categories. So when you see a newspaper, it doesn't have only two different types. We have n number of different categories. We have advertisement, we have film news, we have political news, we have advertisement news. So these are all comes under the multi-class classification. And classifying books, classifying students according to their streams. These are all comes under the multi-class classification. And we have very one of the important research area that is sentimental analysis of a person. If I want to do a sentimental analysis of a person, we can't say that a person is positive or negative. We have many other things. Like we can also find out whether a particular person is sad, happiness, disgusting, or depressed. Like this we can find. So these are all comes under the problem of multi-class classification. And coming to the methods that can be used for this multi-class classification includes one versus rest and one versus one. So this is the multi-class classification where we have three different categories. So what do you mean by this one versus rest? Okay. So it involves creating three binary classifiers. One versus rest classifier. Let us see with one example. See, here, this is one versus rest. So we have three different categories. One is green, red, and blue. As we told earlier, we have to generate the same number of classifiers as the class labels are present in the dataset. So as we have, it is a 3, we have to implement 3 classifiers. So how we are going to create that 3 classifiers is when you take a classifier 1, if you take green, that versus red and blue. If you take blue versus green and red. If you take red, it versus blue and green. Like that, if it is 3 different classes, so compulsory we require 3 different classifiers. That is what the one versus rest. Okay? And you see this particular data set. If a particular color is, if you has feature x1, x2, x3, we are concluding that this class belongs to green. Similarly, if you have feature x4, x5, x6, it is blue. Likewise, according to the features, we have differentiated these classes. So class 1 is green, 2 blue, and 3 red. Now, see here the same data set. The first row we have x1, x2, x3. First we are giving a training data set to the class 1 that is green. So for that particular class 1, wherever we have green, we are going to keep it as +1, remaining all -1. Similarly for blue, Wherever blue is there, that we are going to keep it as plus 1, remaining minus 1. And we are giving a training data set for red, where we have red this and this. For that, we are going to use plus 1, and remaining all we are going to give the minus 1. In this way, it works 1 versus rest. And what about this 1 versus 1? So in 1 versus 1 classification, if we have n class instances, we have to generate n into n minus 1 divided by 2 binary classifier models. Okay, so in 1 versus 1 multi-class classification, we split the primary data set into one binary classification data set for each pair of classes. You see this here example. So it is first we have taken these two, then these two, then these two. Earlier is like green versus red comma blue. Here it's not like green red, red blue, or blue red. Like that we are going to create 3 different classes. Now taking the example of earlier, okay, we have a classification problem having 3 types, that is green, blue, and red, where we have n equal to 3. So we will divide this problem into n into n minus 1 divided by 2, which is equal to 3. So we require 3 binary classifiers. Even though it is multi-class, when we use 1 versus 1, that with the calculation of this, that we are going to convert it into binary classifier. So that classifier 1 will be green versus blue, second one is green versus red, and blue versus red. Like this, we are going to construct the 3 classifiers. And each binary classifier predicts one class label like this. This predicts one classifier. When we input the test data to the classifier, then the model which having the majority counts of these, then that will be concluded as a result. Now, what is the difference between this binary classification and multi-class classification? So here we already know that only 2 class instances are present, but here we have multiple class labels. And it requires only one classifier model. But coming to here, depending on the classification, if it is 1 versus all, for n class instances, n binary classifier models are required. And 1 versus 1, n class instances, when we require n into n minus 1 divided by binary classifier models. And confusion matrix is easy to derive, understand. And confusion matrix is of course easy to derive, but complex to understand. And this is the diagrammatic representation of binary classification, and this is a multi-class classification. Then multi-label classification. Till now we discussed binary and multi-class. Here we are discussing about the multi-label. So what is this multi-label classification? Well, let me explain you with one example. Suppose you see this picture. What if I ask you that this image contains a house? Yes, the simple answer you'll give that yes or no. But consider another case where I'll ask what are all things. The things is nothing but the labels are relevant to this picture. So I have written here the labels. House, yes. Tree, yes. Beach, no. Cloud, yes. Mountain, no. Animal, no. So these types of problems where we have set of target variables, not single variable, but we have a set of target variables, we call them as the multi-label classification problems. Okay. Even I hope you understood. Okay, where we have a set of target variables that we call it as a multi-label classification problems. I'll explain you. I'll make you clear this. What is multi-class and multi-label with one more example. See here. Let us see what is this multi-label versus multi-class. For example, if you look into this picture, this movie has been rated as U by A. Okay. And we know that we have also other types of certificate classes like A, RU, restricted for adults or unrestricted public. Like we have different types. But it is sure that each movie can only be categorized with any of this. U by A, R A, U. They won't give more than one. They will give any one of this. Yes or no? Okay. So that is nothing but the multi-class classification. So there are multiple categories, but each instance is assigned only one. Therefore, such problems are known as multi-class classification problem. I hope you understood. Again, you look back at the same image here. Okay. This movie has been categorized into comedy and horror. Okay. But there is difference that this time each movie could fall into one or more different set of categories. So when you have watched one movie, if I ask how is that movie, maybe you'll give answer like it is horror as well as comedy, or else full comedy plus sentiment. Like this, we can't give a single answer. We'll give more than one. It will be a more than one. Simple you say only comedy you can't say. Okay, like that, which we give that one or more different set of categories. Those are called as the multi-label categories. So therefore, each instance can be assigned with multiple categories. So these types of problems are known as multi-label classification, where we have a set of target labels. Friends, I hope understood what is the difference between multi-label versus the multi-class classification. Yeah. Then coming to the last one, imbalanced classification. So what do you mean by imbalance? The name itself indicates. So whenever we are giving a data set to a classification model, we should have number of examples for training data set. Okay, where we want to label each class, it should be balanced. Okay, if it is not balanced, then we say that it is a imbalanced classification. That is, the class distribution is maybe not equal or close to equal and is instead biased or skewed. Suppose we are working about some flowers. Okay, we have collected some measurements of flowers, and when we have 100 flowers of two different types, then compulsory we should have 50% of type 1 and 50% of type 2. But we have only 20 examples of this and 80 examples of this. Then these examples we give to the training data set. Okay, this gives an imbalanced classification problem. Then whatever the input, even though you give input of second input, our classification predicts the first one. Why? Because there is an imbalanced data set. So we have to take care of this imbalanced data set to make it convert it into balanced data set, then only we can solve the classification problems. Thank you.